Hello. Good afternoon. Good afternoon, students. So, am I audible? Good afternoon, Sanjana. Good afternoon, Vaishnavi, Anita, Tanika. Good afternoon, dear students. So, can you able to see my screen? Am I visible and audible to all of you? Okay. Okay. Okay, fine. So, today, as I have already told you, we are going to solve some basic level questions from chemical kinetics today. Okay, from all the topics we have discussed in this lesson. So we have studied about rate law and average rate, instantaneous rate, and then we have studied what is meant by an elementary reaction, complex reactions, and we have discussed some formulas from integrated rate law, and we have seen some graphs for it, and half-life formula for zero order and first order reaction. Then at last we have discussed about collision theory, then factors affecting the rate of the reaction. Okay. So from all these topics of this lesson, we are going to solve level 1 questions from chemical kinetics today. Are you all ready? So shall we go with the question? So you guys are going to solve first, and then only I'm going to discuss the questions in the class. Okay. So for each question, I'll give you time. You guys have to give me the answer. Okay. Yes. Okay. Good. So keep a notebook and pen with you. So let's go with the first question. So these are level 1 questions only. It will be very easy for you. Okay. Easy level question. You can solve all the questions within a minute. So try to keep the time limit and solve the questions. Okay. So the first question is, chemical kinetics is a branch of physical chemistry which deals with option 1, structure of molecules, option 2, heat changes in a reaction, option 3, physical changes in a reaction, option 4, rate of the reaction. So chemical kinetics is a branch of physical chemistry which deals with. So which is the correct option? Option 4. Sure. Okay, let's see the solution. So rate of the reaction is the correct answer. Very good. Great. So let's move on to question number 2. Under a given set of experimental conditions with increase in the concentration of the reactants, the rate of the chemical reaction decreases, increases, remains same, and first decreases and increases. So in option 3, it remains same, okay? So same is missing there. Vaishnavi is going for option 2 and Sakshi is going for option 1. Which is the correct answer? Aisha 2, Anita B. Under a given set of experimental condition with increase in the concentration of the reactant, the rate increases or decreases? So many of you are going for option 2. Okay, let's check. Let's check. So yesterday, I think day before yesterday, no, and we have discussed in the factors affecting the rate of the reaction. So the concentration is directly proportional to the rate of the reaction. So rate is directly proportional to the concentration of the reactants. So if concentration is increasing, then rate also should increase. So option 2, increases, is the correct answer. Because in the question they have given, no, with increase in the concentration, the rate should also increase. Clear? Sakshi? I think you only have given me option 1. Yeah. Is it clear now? Don't get confused. Try to apply all the concepts we have studied. Okay? Don't get confused. Now next, coming to question number 3. In a chemical reaction increases with the temperature. Okay, because in the third factor, we have studied about this temperature and rate is directly proportional to the temperature. The reason is due to. So what is the reason behind this? Option 1, number of collisions between molecules increases. Option 2, decreases in activation energy. Option 3, increase in the number of effective collision of molecules and decrease in the activation energy. Kinetic energy of the reactant increases. In a chemical reaction, the rate of a chemical reaction increases with temperature, and what is the reason behind this? Option 3. What about others? Sanika, Aisha, they are going for option 3. What about others? I want answer from all of you. Vaishnavi 3, Sakshi 4. Sakshi is going for 4. What about others? Chandana and Jyoti, Isla, Ismail, Vaishnavi, Pratyusha. What about you guys? What you guys are saying for this? What is your answer? Okay, let's check this solution first. So in a chemical reaction, you are not clear? Which is not clear, my dear? For Jyoti, question is not clear. Question is not clear. Okay, question is not clear. Okay, wait. I'll explain you. Listen. So the question is, in a chemical reaction, rate increases with temperature. Okay. So we have discussed the factors affecting the rate of the reaction in the previous classes. No. So in that 5 factors were discussed. So one is concentration, the other one is nature of the reactant, third is temperature, fourth is light, and the fifth is catalyst. So can you able to recall these 5 points which we have studied under factors? Jyoti, can you able to recall these 5 factors first of all? Jyoti, are you there? Yeah. See, these are the 5 factors which affects the rate of the reaction. And when you come to the third factor, which is temperature, so rate is again directly proportional to the temperature. Means if you increase the temperature, rate will also increase. If you decrease the temperature, rate will also decrease. Okay, so this is a statement. This is a fact. Okay, we have to tell the reason here. Okay, we have to tell the reason here. Got it? So, the reason is increase in the number of effective collision of molecules and decrease in the activation energy. Okay. So, kinetic energy is actually, it will come in Arrhenius equation. Okay. So, that is not the correct reason for this general explanation. So, that will come in the Arrhenius equation. Kinetic energy part will come in Arrhenius equation thing, and in the collision theory, so that thing will involve. Okay. So because the kinetic energy is increasing, the rate doesn't increase because kinetic energy is not directly related with rate. Okay. So the rate is increasing because of temperature due to the effective collision. Because if I increase the temperature, the collision number of collision increases. No, between the two molecules, they increases. and the activation energy is getting decreased and the reaction proceeds very fast. So that can be the correct reason for the rate. Okay, kinetic energy of the reactants also increases, but that cannot be the reason. That is one of the point. Okay. Clear? So, activated molecules are formed due to lower activation energy. So, option 3 is the correct answer. Okay. So, in a chemical reaction, effective collisions results in more products. So, effective collisions are caused by activated molecules, and those activated molecules are formed due to the lowering the activation energy. Okay. So, option 3 is the correct answer for this question. Now, next coming to question number 4. With increase in temperature, the value of the rate constant of a reaction generally. So, what is rate constant? It is denoted by the letter K, right? So, if you increase the temperature, rate will increase. If you increase the temperature, what will happen to the rate constant? So, that is this question, okay? Whether will it increase or it decrease, or it may increase or decrease or may not change. So, which is the correct answer for this? Rate is directly proportional to the temperature. And what about the rate constant? What about the rate constant? Sangana is going for option B. Sakshi is going for 1. Anita is going for A. 1, 1, 1. Okay. Let's check. Rate constant is also directly proportional to temperature. So if temperature increases, rate constant also increases. Okay, like rate constant also increases. So all of you can write down these relations. So in the solution part, we are studying the relations. So rate constant is directly proportional to temperature and rate is directly proportional to temperature. All of you can take down these points, okay, which we are learning from each question. So that will be very helpful for you. Clear for all? So keep a notebook with you. So divide a page into 2 columns and write all the formulas and write all the relations in your notebook, okay? Which will be very helpful. Fine. Now let's go with the next question. Question number 5. In reactions involving gaseous reactants and gaseous products, the units of rate are. This is one of the very easiest question, no? So in gaseous reactant and products, we have to find out the unit of rate. First is ATM, second is ATM second, ATM per second, ATM square, second square. So atmospheric pressure is nothing but ATM. So what is the unit in terms of gaseous reactant and product? Very good, Anita. Why Sanika is going for option 2? What happened to Sanika? It's very easy, no? It is atmospheric per second. Option 3. Okay, atmospheric pressure per second. Okay, don't get confused. Atmospheric per second is the answer. Okay. Sanika, are you clear now? So there is a small change. So that change will cause the wrong answer. So it should be very, very clear. Okay. Yeah, very good. So for gaseous reactants, instead of concentration, partial pressures are considered. So for partial pressure, instead of mole per liter, we have to use ATM per ATM. Okay, so atmospheric pressure per second will be the unit. So let's go with N is the order of the reaction. Let's go with question number 6. In the sequence of reaction, A giving B, B giving C, and C giving D. Okay, so the rate constant associated with each reaction is K1, K2, K3, where K3 is greater than K2, K2 is greater than K1. Then the rate determining step of the reaction is C to D, A to B, B to C, A to D. Which is the correct answer? Option 2, Sakshi has given the correct answer without seeing the options. The slowest step in the reaction is the rate determining step. We have already discussed the statement in the class. Now, in this given reaction, if you see, K3 is the greatest, highest value containing thing, and K1 is the least value. Okay. So, if something is very least, then that is the rate determining step. Okay. Since K1 is the having the very least value, so that is the slowest step. So that is nothing but the rate determining step, and A to B is the rate determining step among these three steps of this reaction. So is this clear to all of you? If the rate constant is very low, then that is the rate determining step of that reaction. So this is the concept you are learning from this particular question. Clear for all? Say yes or no?
Yes.
Yes. Yeah. Okay. Very good, students. So now let's go with question number 7. Okay. Question number 7. In which of the following cases does the reaction go fastest to completion? Okay. K is equal to 10 power 2, K 10 power minus 2, K is equal to 10, K is equal to 1. In which among these four does the reaction go fastest to completion? Anita has given the correct answer as 1. What about others? Sanika is also going for 1. So why you guys are going for 1? Can you give me the reason for this? Can you give me the solution? Can you try the solution? Try giving the explanation for this. So why you guys have selected option 1 as the correct answer? Higher the value of K. What is the relation? Complete the relation, Sanika. Higher the value of K, faster is the reaction. Faster is the reaction, right? So if K is nothing but the rate constant, so if the value of K is the highest, then the rate of the reaction is more. So higher is the rate constant, more is the completion of the reaction. So this is the concept you are learning from this question. So write and keep this in your notebook. If the rate constant value is highest, then the reaction will go very fast. If the rate constant value is very less, then that step is the rate determining step. More is the completion of the reaction. Very good, Anita. Good explanations. Good. So that is correct. Correct. We'll go with the next question, okay? Question number 8. The factor which does not influence the rate of the reaction is very easy question. The factor which does not influence the rate of the reaction. Option 1, nature of reactants. Option 2, concentration of the reactant. 3, temperature. 4, molecular mass. Which is the factor which does not influence? Sakshi 4, Anita 4, Vaishnavi 4. Okay, everybody's eyes are on. Everybody is going. Okay. Let's check whether your answer is correct or not. Talzeen is also going for 4. Okay, let's check. Okay. Your answer is correct. All of your answers are correct. Okay. So our correct answer is option 4, molecular mass. So what are the factors which influence the rate of the reaction? Nature of the reactant, concentration, temperature, light, and catalyst. Right. So these 4 are the factors which affects the rate. Molecular mass is not the factor which affects the rate of the reaction. So that is the correct answer. Good. Next, coming to question number 9. The rate of chemical reaction depends upon the nature of the reactant because. So what is the reason for the dependency of this rate on nature of the reactant? Okay. So nature of the reactant, just keep that in mind. recall all the concepts which we have studied under this topic. Okay. And option 1 says that the number of bonds broken in the reactant and the number of bonds formed in the product changes. Some of the reactants are solids at room temperature. Some of the reactants are colored. Some of the reactants are liquid at room temperature. So what is the correct reason for this? We have studied that rate is directly proportional to surface area, right? So under nature of the reactants, we have studied this relation only. So which is the correct answer? Sakshi 1, Sanika 2, Aisha 1. What about others? Because Chandana, you guys are not answering. Why? Two Sanjanas are there. So try to answer, my dear students. 1. Jyoti is going for 1. Okay, let's check. Let's check. Let's check the solution. Correct answer is option 1. So for ionic compounds, the rate of the reaction is very fast, but in covalent compounds, it depends on the number of bonds breaking in a reactant and number of bonds making in the product. So that is the reason for the given question. Okay. Okay. No, they are asking the reason, no, my dear. The rate is depending on the nature of the reactant, because some of the reactants are solid, not, it is giving the reason only for some reactants, no, but we need the answer, we need the reason generally for all type. Okay, so rate depends on the solid, so that cannot be the answer, no, because it talks about only very few reactants, not about all. Got it? So what if I increase the temperature or decrease the temperature of that reactant? Obviously, the nature will change, no? So suppose if I increase the temperature of the solid, what will happen? Solid may turn into liquid if I increase the temperature. In that case, if the temperature changes, then the nature of the reactant also changes, no? So in that case, rate cannot be depend on the nature of the reactant. So that cannot be the answer. Got it, Sanika? Sakshi, you have sent me a message, no? You want to write this? Which one you want to write, my dear? Which slide you want me to show? Last means what? This particular slide of this explanation? Is this the slide you are asking for? Okay. Okay, take down the concept or take a screenshot. Finished? Yeah. So let's go with the next question. Question number 10. Dimensions of rate of reaction involves concentration only, time only, both concentration and time, neither time nor concentration. Dimensions of rate. So rate is equal to minus dc by dt, right? So what are the dimensions involving here? Option C, very good. So it involves both concentration as well as time. Very good, students. So option 3 is the correct answer. It involves both time. It is directly, rate is directly proportional to concentration and inversely proportional to time. Very good. Question number 11. For the reaction 2NO2 giving 2NO plus O2, which of the following is false? Which of the following is false? The decrease in NO2 and increase in NO proceeds at the same rate. Okay. The rate of formation of NO is twice the rate of formation of O2. The average rate of increase in concentration of NO and O2 are expressed as dNO by dt and dO2 by dt. dNO by dt is equal to dO2 by dt, which is the incorrect option, which is not correct for this given equation. Maybe 3. Aisha, Sanika, they are going for 4. Anita is saying maybe 3. Okay. So try to write the rate equation for for this given reaction. So how to write the rate equation? So minus 1 by 2 dNO2 by dt, which is equal to plus 1 by 2 dNO by dt, which is equal to plus 1 by 1 dO2 by dt, right? So this is the rate expression. This is the rate expression. So now if I compare only these two, if I equate only these two, I can take this 2 to the other side. It will go to the numerator. So I will have dNO by dt, which is equal to 2 into dO2 by dt. So I'm getting this relation, right? I'm getting option 4. Option 4 is the correct answer only. So why you guys are going for option 4? So see here, we are getting option 4. It is correct. By rearranging, we are getting option 4 as a rate for this given reaction. So that is the correct relation only. That is not the answer. So you have to find out which is false. So the answer is lying between option 1, 2, 3. At last, Sanika came to the conclusion that answer 3 is the correct one, I think. Sakshi is going for 1. Okay, I'll explain you. Listen, come to option 1. The decrease in NO2 and increase in NO proceeds at the same rate. So since both of them are having the same coefficient, the decrease and the increase proceeds at same rate. So that is correct. Okay. Anita, oh, that one is Anita. Yeah, Anita only gave option 3. Okay, Anita, sorry. So that is correct. The rate of formation of NO is twice the rate of formation of O2. Yeah, rate of formation of NO is twice the rate of formation of O2. That is also correct. The average rate of increase in the concentration of NO and O2 are expressed. So here, if you see to the rate, both are equal, but it is not correct. No, so here we have to have 2, but that 2 is not given in the question. So option 3 is the false statement. So this is the required rate equation and option 3 is the incorrect answer. Okay. Clear for all? Shall we move on to the next question? Okay. So question number 12. Question number 12. The term dC by dt in a rate equation refers to concentration of reactant, change in concentration of reactant or product with time, velocity constant of a reaction, concentration of products. Option 2,
Two.
term dC by dt in the reaction. The term dC by dt in a reaction, a rate equation refers to change in concentration of reactants or products with time. Very good, students. So 2 is the correct answer. Now next coming to question number 13. The rate constant is given by the equation K is equal to A into e power minus A by RT, which factor should register a decrease for a constant reaction to proceed more rapidly. So this is an Arrhenius equation. Which factor should register a decrease for the reaction to proceed more rapidly? So if the reaction has to occur very fast, then which factor has to get decreased? Temperature, rate constant, A, frequency factor, and at last, activation energy. Which one is the answer? Which factor has to get decreased for a reaction to occur very fast? Option 4. Tanika is going for option 1. Others are going for option 4. Okay, let's check. The rate of the reaction is inversely proportional to activation energy. If the activation energy is very less, then the rate of this reaction is very high. Okay, so the correct answer is EA. So EA has to get decreased for the reaction to proceed more rapidly. Rapidly means very fastly. Okay, clear. So it is clear for Samika. Very good, dear. So all of you write this relation. Rate of the reaction inversely proportional to activation energy. So you can write this relation. So I'll move on to question number 14. In Arrhenius plot, the intercept is equal to. So what is the intercept? Minus EA by R, ln A, ln K, log A to the base 10. Who is the intercept in Arrhenius equation? K is equal to A into e power minus EA by RT we have, right? So we have applied log on both the sides and we have arrived at a straight line equation, no? For Arrhenius equation, in that what is intercept? What is actually intercept? Y is equal to mx plus c and the c is the intercept. So here which term is written as an intercept? ln A. So this is the logarithmic form of Arrhenius equation, and here y is equal to log k and intercept is log a. Very good. Very good, dear students. So it is option 2. Okay, moving on to question number 15. In the reaction A giving B, if the concentration of A is increased by 4 times, the rate of the reaction becomes doubled. The order of the reaction is. So here I have only one reactant, okay? We have to find out whether it is 0, 1, 1 by 2 or 2. So if I have to write the rate for this given equation, then I will be writing K into A power something, N, okay? Where N is the order of the reaction and that only we have to find out. We have to find out that order N only, okay? So what is the given information? If I increase the concentration of this A by 4 times, the rate is doubled. If I increase the concentration of A by 4 times, then the rate of the reaction is doubled. If I take this rate as R, by increasing this to 4 times, it is becoming 2R. So what could be the order of this reaction? What could be the order of this reaction? So what will you substitute here? When will the rate get doubled on increasing the concentration of A by 4 times? Option 3, Sanika, what about others? Others are struggling to solve this question or what? It is very easy actually. See, listen. If I put Sanika gave option 3 as the answer. No, let me substitute n value as 1 by 2 according to her option. So I'll get K is equal to 4 into A power 1 by 2. So here I have 4 power 1 by 2, which is nothing but root 4. If you take root 4, it will be equal to 2. So what is happening? The rate is getting doubled. If I substitute n is equal to 1 by 2, the rate is getting doubled. Clear? You can, so option 3 is the correct answer. Option 3 is the correct answer. Yeah. Can you all able to understand how to solve this? Okay. Very good, students. Question number 16. The unit of rate constant for a second order reaction is very easy. Liter per liter second, liter mole second, mole inverse, liter second inverse, mole second. The unit of rate constant for a second order reaction is. So what is the formula I gave you to find out the order of the unit of the rate constant? So it is mole per liter power 1 minus n into second inverse. So this is the formula, no? So second order means here n value is equal to 2. So what I will get? So it will be mole by liter minus 1 second inverse. So which is nothing but mole inverse liter second inverse. Right? So option 3 is the correct answer. Option 3 is the correct answer. Okay. So guys, can you all able to understand? Only very few students are answering. Is it clear to all? Yes. Anita, Vaishnavi, Vikas, Sanjana? Yes
Yes.
or no? Okay. Question number 17. Okay. A chemical reaction A plus 2B giving AB2 follows in two steps. A plus B giving AB, which is the slow step. AB plus B giving AB2, which is the fastest step. Then the order of the reaction is 3, 2, 1, 0. What is the order? How will you find out the order? If for complex reactions, 2. Very good. So why option 2 is the correct answer? Why option 2 is the correct answer? Why everybody is going for option 2? Very good, Vaishnavi. So because the slowest step determines the reaction rate, right? Yeah. The slowest step is the rate determining step. And in that slow step, we have two reactants. So the order of the reaction is 2. Order of the reaction is the number of reactants involved in the slow step. So in the slow step, we have 2 reactants. So yeah. So the answer is option 2. Tanika, good. Slowest step is considerable. Very good. We'll move on to question number 18. When molecules of type A react with molecules of type B in one step process to give AB2, the rate law is, we have to find out the rate law. The 4 options are given. A is reacting with B to give AB2. A is reacting with B to give AB2 and we have to find out the rate of this reaction. Which is the correct option? Which is the correct option? Option 4. No. We have to balance the reaction, no? We have to balance. We have 1A and 2B. So you have to put 2B here. Then only the reaction will get balanced. Now if you write the rate for this reaction, it will be K into A power 1 and B power 2, right? Yeah. So which is the correct answer? Which is the
1.
correct answer? Option 1. Option 1 is the correct answer. Okay, clear guys? So if some questions are given like this, what you have to do, balance the reaction first and try to recollect the concepts. Got it? You have to put the coefficient in the superscript, right? So you need to balance the reaction first. So these are the very silly mistakes we used to make in the examination. So don't do that. Try to understand the question carefully and give the answer. Let's move on to question number 19. Minus dNH3 by dt represents formation of ammonia, decomposition of ammonia, consumption of N2, consumption of H2. What is this D minus dNH3 by dt denotes, represents? So minus actually denotes the decomposition. Very good. So it denotes the decomposition of ammonia. So the rate is decrease, negative in concentration of reactant or increase in concentration of product. So minus dNH3 by dt is decrease in concentration of NH3. Okay, very good. So coming to next question, the order of a reaction can never be zero, can never be fraction, must be a whole number, can be an integer or a fraction or zero. What is the answer? We have studied now the differences between order and molecularity. Option 3 or option 4? 4? Okay, let's check. It is option 4. It can be an integer or it can be fractional and it can be 0. So this is the point we have discussed. Very good, students. Now moving on to question number 21. For the reaction A giving B, the rate law is rate is equal to K into A power 1, concentration of A to the power 1. Which of the following statements is incorrect? The reaction follows first order kinetics. The T half of a reaction depends upon initial concentration. K is constant for the reaction at constant temperature. The rate law provides a simple way of predicting the concentration of reactant and product at any time after the start of the reaction. So, which is the incorrect statement? So, before moving on to the answer, you tell me the order of the reaction first. What is order of the reaction? You get from by seeing the rate equation. What is the order for this reaction? Yeah, it is 1. So the order is 1. It is a first order reaction. Now try to find out the answer. It is a first order reaction. Try to find out the answer now. Which option is correct? Sorry, I mean, which is the incorrect statement and the correct answer? Which statement is incorrect? What happens, students? Which is the correct statement? Correct answer? Which is the correct answer? You think 4. Anika is thinking 4. She's not giving 4, she's thinking 4. What about others? Sakshi, Isla Ismail, Chandana, Sanjana. What about you, Tazeen? Tazeen is going for 4. Okay, listen. Option 2 is the correct answer. Why you guys are going for option 4? Since that looks very big, you guys are going for that option or what? Huh? See, for first order reaction, I told you the half-life is independent of the concentration, right? So what is the T half for first order reaction? It is 0.693 divided by K. No. So here, no concentration term is involved. So T half is independent. But in the given statement, it says that T half depends upon the initial concentration, which is the incorrect statement for first order reaction. Able to understand? Don't go for the option which looks lengthy. Okay, it won't work out in all the cases. Clear for all of you? Yeah. I'll go with the next question. Question number 22. The rate expression for a reaction is given. The overall order of the reaction is 2, 1 by 2, 3 by 2, 1. What is the correct answer? What is the order of this reaction? Very, very easy question. Sakshi is giving option 1. Very good. So what we have to do to find out the overall order? Add two numbers, you will get the answer. Yeah, everybody is getting the answer. Very good. 1 by 2 plus 3 by 2. So 1 plus 3 denominators are same. Just add the numerator 4 by 2. 4 by 2 is nothing but 2. So option 1. Option 1 is the correct answer. The overall order of this reaction is 2. Okay. Next, the hydrolysis of ethyl acetate is given. Ethyl acetate is an ester, and ester is undergoing hydrolysis in presence of acid to give ethanoic acid and ethanol. Okay, and it is a reaction of pseudo first order, second order, third order, zero order. So the given reaction is an example for which order? Very good, Vaishnavi. Great. Yeah. So option 1. So it is an example for pseudo first order reaction. So only 2 examples we have studied, no? Hydrolysis of ester and the hydrolysis of sugarcane. So those 2 reactions are the examples for pseudo first order reaction. So this is the hydrolysis of ester. So option 1 is the answer. Good. Coming to the next question. The rates of the reaction at different times are given below. So at time t is equal to 0, at 10th minute, 20th minute and 30th minute, rate values are given. The order of the reaction is second order, zero order, third order, first order. What is the order? What do you observe and what do you understand by seeing the data? At time t is equal to 0, rate is 2.8 into 10 power minus 2. After 10 minutes also, it remains same. After 20 minutes also, it remains same. After 30 minutes also, it almost 2.79 is nothing but 2.8 only. It remains same. So what do you understand? What could be the order? When does a reaction rate doesn't change even after changing the time? Even after changing the time. When does a reaction rate remain same? For which order? First order. Option 2. It is zero order. Why are you thinking this much? Only for zero order reaction, the rate of the reaction doesn't depend on the time, no. So for zero order, rate is equal to K into A power 0, A to the concentration. A to the power 0 means it is nothing but 1. So rate is equal to K. So even if you increase the increase the concentration, rate is not going to get affected. Clear? Yeah. It is zero order. The answer is option 2. Answer is option 2. So I'll go with one more question for today's session. So we are running out of time. So this is the last question for today's session. The remaining thing we will continue in the next class. Okay, so a zero order reaction is one whose rate is independent of temperature of the reaction, concentration of the reactants, concentration of the products, the volume of the vessel in which the reaction is carried out. A zero order reaction is one whose rate is independent of. Very good, Vaishnavi. Option 2. For a zero order reaction, now only I told you, no, the rate is independent of the concentration of the reactant. Okay. So very good, Sanika, and very good, Sakshi. Good. It is independent of the concentration of the reactant. So this is enough for today. So I think the session is very useful for all of you. Can you all able to understand and can you all able to apply the concepts which we have studied in the theory sessions? Yes? Okay. So in the next session also we will discuss some more questions, little bit higher level. Okay, little bit higher level questions we will discuss. And after that, we will go with the previous year's questions of this lesson. Okay. So today we did not see much numericals. So mostly we have studied the, what to say, some conceptual understanding part of this lesson only in terms of this MCQ. Then in next class, and after that, we'll go with the numericals and other things. Got it? Okay. Thank you, students, for listening to today's lecture. See you all in the next class. Till then, take care. Bye bye. If you're having any doubts, you can ask me now. If you're having any doubts, you can ask. No doubt? Okay. Bye bye. Bye, Sanjana. Bye to all of you.